There, folks, here we are doing some Khan Academy differential equation problems. First one is simply verifying a solution to a differential equation. All we need to know is, are these going to be compatible statements? Is it true that the derivative of y with respect to x is y times 2x minus 5 when I substitute in this function for y? Well, so first thing we need to do is come up with the actual derivative of this. So I've got this on another page here, and you can see that there's the statement and there's the possible solution. So I've just taken the derivative of my y value here, and I've got the chain rule going on. So I just take the derivative of e to something and then times the derivative of that something. Don't forget that minus sign is there in the beginning. And then what I've done is I've substituted that in for the dy dx, and then I've substituted in here the minus e raised to the x squared minus 5 in for the y right there. So here are the two substitutions. My derivative I took here on the left, and then in place of y I'm putting the function, and you can see quite clearly that even though the multiplication order is different, everything checks out. So yes, I would say yes, that is a solution. Let's see, hope I'm right. Go back and click yes, and I am. All right. The next one is writing a differential equation. Okay, so they'll describe in words some relationship. This can be quite tricky. I'll go through this here. It says the amount Z of chemical in a tank, so like salt has dissolved in water or something like that, and it's decreasing at a rate that's proportional to Z. So the more salt there is, the more quickly it decreases, and inversely proportional to the volume of the solution in the tank. Okay, so when something is proportional, you just need a multiplied proportional constant, and if it's decreasing, we can assume that that is going to be a negative sign. Occasionally you'll have just k and you'll solve for k and k will turn out to be negative, but I think the assumption here is that we're going to put a negative sign in there, so we're looking for um, a negative kz, and then inversely proportional to the volume. Okay, well they're telling us here that the volume is being diluted out of the tank. The chemical is being diluted by pumping pure water in at this rate here. So if it's inversely proportional to the amount of volume, this is going to be in the denominator. So where do we see a negative kz with the 20 plus 2d and the 2t in the denominator? It's right here. Why is it not this one? Because it's not a subtractive process. You can't just sort of take an amount like this and subtract it. Plus the hint there is that there's no negative k. So I'm going to click on this guy, and lucky for us, we're still going. Next one is a slope field problem. Here I've got 4 options. Let's go to this original differential equation. What you're looking for, I think, is a simple pattern that will help you identify. And I like to go with like slopes of 0. I think that's an easy way to go. And you can ask yourself, when is the slope going to be 0 for this? Well, it's going to be at 0, 0. It would be at 1, 2, at 2, 4, 3, 6, 4, 8. And if you look at your options, here the slope is 0, 0. At 2, 4 it's 0, at 4, 8 it's 0, so that one looks very promising right off the bat. Here it's 0, but then it's going 2, 2, 4, 4, 6, 6, so that's not it. Here it's 0 at the origin, and it's not 0 at 2, 4. Here it's not 0 at the origin, and here it's 0 at the origin and not. So I'm going to go with A. First one's the good one there. Okay, then next one is reasoning using a slope field. If the initial condition is 0, 0, what's the range of the solution curve? Okay, well, if I'm starting at 0, 0 and I'm following my little slope field here, I'm going to curve on up, but then I'm going to come and bend over to this as an asymptote. That's at 1.5. If we're starting at 0, it's going to be a bracket. If we're a boundary at 1.5 and can't be there, it's going to be a parentheses. And so I'm looking at C right there. Finally, we've got a separable differential equation that we're going to solve. here we're given the differential equation is 3x squared over y squared. The game here is to get the y's diagonal and the x's diagonal. Sometimes you have to do some clever algebra with your exponents, but this is quite easy. I'm going to go back to my work page and show you how to do this step by step. So looking at this, you can see here's my original separable differential equation. Not all of them are separable, but this one is. When I do that separation and I put in my integration, I get this. Then when I perform that integration, it's usually quite simple. Just don't forget the constant. Because you'd sort of throw a constant on both sides, we just send, constant from here over to this side. It's still just a constant of adjustment, and I want y equals. When I substitute in my values to solve for c, I get c is equal to 8/3. When I plug that back into my original solution and then solve for y, the algebra takes me to this solution right here. Okay, so let's hope that we go and find it. And that is it at the top, I believe. Yes. There we go. Hope that works.